Hey Hajime no Uni, how's it going? Control Byte, how's it going? Clicky clacky. Yeah, I just got home. I just drove home from a skiff that I was working in. I know I've been working a lot out, so I've been trying to hop in and maybe have some talks with you guys and get into some system stuff. We're gonna talk tonight. I've got a couple of talks that I haven't done in a while, so I figured I'd just pop one up and go through it a little bit for you guys. The main one tonight will be around computer, actually not even just computer, but compute and data security. So when I say compute, I'm talking about one of the four big components of like a high performance compute type system. We've got compute, we've got the network. I'm tired. We've got compute, we've got network, we've got the back end storage typically, and then I guess those would be the big three of that. But within a system, we have the CPU, the memory, the disk, and the network. Obviously, those are the big four of a system. I don't know. I'm just losing my mind today. I'm a little bit tired, but we'll get through it. So today we're going to talk about a little bit with compute and data security, and I'm going to tell you guys a little bit about some of those concepts, and we'll just kind of mash through them and do some Linux while we're at it. Let me reconnect to my home lab. I'm not even connected, I don't think, to any home. Nope. I'm not even on any home systems right now. So let's get connected. Pull this up over here for you guys. You guys haven't seen me ever connect to my home lab, right? Just jump on in. The water's warm. And then once you get in, you typically check, if you do like I do where you can leave a system at any time, you check to see what you have available. And for me, I tend to have the stream is one of the things that I will use. My streaming. I have this other one. This is work stuff. I do work stuff out here too. So I want to do something like this. Screen dash R because it's detached. I could use a dash X if it wasn't detached. And I'll just connect to that screen session right there. Boom. And then we'll be back exactly where we were last night when we were in here working on stuff. So that's how I try to remain somewhat productive. I treat every Linux box as though the connection to it's ephemeral. So any box that I really care about connecting to, I do a no-hup and detach myself from it with the screen session, which is super, super useful, guys. It's really like one of those things that'll be, if you start using that, screen or Tmux, I don't care what you use, it will be a next level thing for you from like an administration and systems engineering standpoint. You can get in there and you can do whatever you're doing. Okay. All right. So compute data security. I originally presented this a while back. I probably need to go through and start rehashing some of these. So maybe I'll take some notes as we kind of go. So Control Byte. I see that you resubscribed last night with Prime. I probably said something about it, but I appreciate that. Thank you. So let's go over this. So here's our overview. And this might look like something that I would give to a college class. I've never given this presentation to a college class, but this is exactly the same type of slide deck that I use for my college students. So if you're like, oh man, this guy sounds like a rambling college instructor, well, that's kind of what I do. Hey chat, how do you guys deal with learning too much on multiple varied things? Isobu, because I do that too, and that's actually a very big problem for people in Brazilian Jiu-Jitsu as well. There's so much coming at them. Isobu, I would tell you just, yeah, don't try to learn everything. Understand that, you have to understand how your tools work, and you have to understand how systems work. And then everything else can either be read as a man page or RTFM, right? Read the field manual, or Google. I haven't had Google, guys. When I'm down in the skiff, I can't Google things. I don't have a connection out. So everything I was doing today to try to get these systems working correctly. And by the way, I got everything working correctly except for, well, so what happened was sometimes when you work in a skiff, let me show you guys this. Typically, there's security protocols of some type, right? And you're going to have all kinds of different compliances. But one of the things that you're not going to be allowed to do is you're not going to be allowed to. Oh, is this the only place that's going to let me draw? All right, well, we'll go over here. One of the things you're not going to be allowed to do is just this anymore. So if you've ever been on a network and everybody just does VLAN, right? VLAN 1. You can't just have all the nodes in one VLAN anymore. When you get into a SCIF, you've got to have, typically it's going to look something like this. You'll have, you're going to have a management network, so management, and then that's going to be, then you're going to have your, typically like a DRAC, or what we call iDRAC, and it's a lowercase I, or sometimes IPMI, or sometimes this is what's called BMC. I don't know what BMC stands for, but those are all ways that we can get to a system remotely, right? And then typically then we'll have like internal, maybe internal can be like maybe provision, and then maybe you've got your IB, which is your InfiniBand, and that's its own network. And then typically you'll have, in this cluster that I'm working on, a storage network, and then you've got a different network over here, which is simply your external. So this is management here, MGT. So now you used to have everything in one VLAN and everything was all good and everybody was all happy with life. And then the next thing you knew, you did this and all the networking broke and all the networking looked like this. Super unhappy. And that was me all day too, trying to get these damn systems to work. And it was funny because we were renaming the internal nodes, which is its own little fun thing. And then after we got done renaming the nodes and re-IPing them, everything broke. And I was like, wait a minute, did we just break everything? Or did those networking guys over there doing shit with the VLANs? Well, it was definitely the network guys, because we found later that we couldn't provision anymore. So I spent half the day trying to trick this cluster into working again after it broke in half. And man, there's all kinds of things that can happen in life, right? But like I was telling you guys down in our Discord, like, man, sometimes it's just something simple. I tricked it with the basics. I went and tricked this cluster in a way that you would trick like a small child by giving them something shiny so that you could take their ice cream from them or something like that. Anyways, yeah, I got kids, so you know, I'm good at sneaking things from them. Anyways, all right. So anyways, I'm just kidding, but this is what we're talking about: protecting data security. We'll talk about the CIA model. You guys have probably seen that a million different ways. We'll talk about defense in depth and why defense in depth is so important. You can't trust. This is actually a cloud thing. I learned this from studying AWS over the years, and I really do like it. It's everything will fail. Every piece of hardware you've ever worked on or every piece of hardware you've ever used is going to fail. It's going to. In fact, it's probably going to fail more often than you want it to. In fact, if you were to go study mean time between failures, MTBFs, right, mean time between failures, you would find that the crap that you buy probably always breaks before you expect it to, right? In fact, there's whole science branches around making sure that things last just as long as they should. I've told you guys about that, working with satellites over the years, and we found out that a low Earth orbit satellite's going to come down every 5 to 7 years. So why would you build a gyroscope for $680,000, a gyroscopic part that costs $680,000 that would last 30 years, when you can do the same part that's going to last for 10 years for $30,000? Well, you know that satellite's not going to be up in the sky more than, you know, in operation for more than 5 to 7 years. 7 years at its best. Low Earth orbit's always falling. It's always falling. It's always gonna land eventually, right? And you might say, what's the difference between 5 and 7 years? How easily and how well they get it down into the proper orbit, right? And there's a certain like burn rate when you first put a satellite up there to get it into orbit. I was talking to my college students about this last night. But other things about data security. You've got all this stuff out in the cloud that you can go do. You can be... Oh, shoot, that just reminded me. I need to... Oh, I'm putting it in my notebook right now. Hold on. I'm writing it in my notebook. Give fishermen access to cloud. I need to give fishermen access to the cloud. I forgot about that. Thanks for the follow, Era Mirazin. Hopefully this stuff's useful to you. Yeah, I have to give them access to my cloud. But here's the thing. How am I going to give them access to the cloud? There's a few different ways that we access the cloud. But at the end of the day, it always comes down to an API, right? And how you access that API is going to be, are you going right into a console and doing like event-driven stuff, and maybe you're showing a manager, or you and somebody else are like working through it for the first time, or you're going doing all these cool labs that are out there that are free. I mean, I just look. You can't come to me and seriously tell me that you like, oh man, I really want to learn AWS or Azure or Google Cloud Platform, but I can't, I can't do it. And I'd be like, dude, I got my first 3 AWS certs and I spent less than 47 cents in the cloud. Everything was free. Literally everything I did was free. I think those 47 cents were because I was already like doing stuff for those 3 months in the cloud. My point is, you can do. I mean, and okay, let's say it's $7. That $7 is probably what you pay for a coffee nowadays, right? Like you can do this stuff. Is my point. So we'll talk about how you access the cloud, and then we'll talk about data security, which is data at rest, data in motion, data in use. There's all kinds of added and things that come around to this. We'll talk about that. We'll talk about protecting those compute resources. At the end of the day, something has to process something. At the end of the day, if we're even talking any type of computer science, it has to be input, process, output. That has to happen. We can do just input, process, and store, or we can do just input and but the point is, you have to do these things. This is like a computer science thing, right? We'll talk about some encryption techniques. Are we doing symmetric encryption, asymmetric encryption? And I'll talk about how that deals with SSL and TLS. What are they? What's PKI? I always bring up the same thing. Some of you guys are probably like, oh God, he's going to mention page 42 of that damn book again. Yeah, I am. Because guess what? Most people I know don't learn SSL and TLS well enough to feel confident talking about it. And you should. But what makes any of the other people that do that smarter than you? Nothing. They're not smarter than you. They just happen to sit down one day and read something or find a good blog post. Well, I'll show you a good book that'll, and it's free, by the way. It's a free book. That'll get you there. Since I brought it up, I'll just pull it up real quick. It's Spiffy, Solving the Bottom Turtle. This is a free web book, free thing out there. One of the members of our community is one of the authors on it, and it was it's a way to talk about security. Let me link this out to you guys on YouTube and over here on Twitch. And again, go down to page 40. Go find page 42 of this book. If you're like, hey, Scott, I've never done anything with certificates, it's like page 42. That's right here. And it just gives you this quick little run through on how X509 certs work. And you say, what's an X509 cert? Well, you're about to read about it. And that's about to be your master class for free from them on. And now look, the whole book is great. But I'm just trying to get you guys to understand this one little piece because it's valuable. Understanding how certificates work. What does it mean to be asymmetric keys? What does it mean to have cryptographically significant or cryptographically similar but significantly different components to a key? So there you go. All right. And then troubleshooting in the cloud. Common issues. Build security into your deployment. All the cloud people are going to say this. All of them are do that. Yes, what does it mean, guys? Yeah, I'm out in the wild. That's true. Actually, I was out in the wild today. I was over. I was over in what's it called? I was over in Chandler, which is about 45 minutes away from me, in good traffic. In bad traffic, I think today it maybe took me, I don't know, probably about 50 minutes to get home. 50 wasn't too bad, under an hour. But the skiff is, guys. I'm telling you, it drains your energy. It's cold in there. It's loud. And you say, is it cold? Well, it's cold if you sit in front of the rack. It's warm if you sit behind the rack. Like, this is data center work, right? But I'm building a big cluster. Well, I'm putting the finishing touches. It's SCIF. It's the Secure Compartmental Information Facility. It's a U.S. government facility typically that you can only go into with U.S. Not AUS. Gosh, man. Come on. Not AUS. United States of America. And I'm proud to be... No, I'm just kidding. I'm not going to sing. All right. I'm done. I'm not singing. Yeah, Australian facility. But we build security into our deployment. All the cloud vendors are going to tell you guys to do that. Otherwise, you're going to look like this. It's hard to slide security in later. I always give this example, but like you can't make a bed when you're in it. But I bet some of you are pretty athletic and you can make a bed when you're in it. But I'll tell you what, you can't put a tablecloth on a table when people are eating on it. I'd know that's for damn sure. What if a waiter came up and started trying to put a tablecloth on your table while you were all sitting there eating? That would be a real... Well, it would be funny if they managed to do it, but also it's not going to work. There's too many things. There's too many. So build security in first. Don't try to lay your security in after. You will not ever... Guys, this is a truth of root in a systems engineering. And if you don't believe me, go be a systems engineer for years and then give somebody in your organization root. You will never get root back from them. You will never get root back from that community. Yeah. All right. The big guy, hopefully this stuff's useful to you. Thanks for the follow. All right, let's go through a little bit. Protecting data security. So I said that we were going to talk about the CIA, and the CIA has been hammered and beaten and this and this and this, and I get that this is simplistic stuff for people that are in security, but some of you guys, you sit around and you do sound engineering. Like one of my buddies that raided me yesterday, Sid Heresy, he does sound engineering, but I guarantee you he doesn't want somebody mucking around with his equipment that he can't see when he's at a facility. He doesn't want somebody over there like hitting it with a wrench or something. So we build security into pretty much everything we do, even if we don't mean to. We just have a hard case on a thing and it's hard to take apart, and maybe use special type of little screws so it's harder for somebody to take them, that kind of stuff. But over here, guys, the CIA triad, right? Confidentiality, integrity, availability. This is how we do security. This is the basics. Everything branches from this. Confidentiality is who can look at it. Confidentiality deals with it's only being viewed by its intended recipient or at the intended distribution point. So, if we want to have confidentiality in a system, we need to understand access and control and then audit of who has looked at things and who hasn't. If we're going to deal with confidentiality, we probably have to deal with tiers of security. That's TIERS, tiers. In that we're talking about, somebody has to start labeling this. ICQ, this is basic education. We're just talking about systems and security. The topic here is compute and data security around systems. There's tiers of security when there's a breach. Sure. Yeah, but now we start to label it. But there's also somebody who owns that data in your organization. And the owner of the data can put the label and they can deal with distribution of it. But look, the owner of the data is probably some C-level or high-level person in charge of something, and they make decisions around that data. And then there's people that are stewards. And stewards are people who hold something until the king returns, right? Who was the steward of Gondor? Does anybody remember? The two sons of the stewards of Gondor were Faramir and Boromir, right? You guys don't know that? Get out of here. Get out. Go. If you didn't know that... No, I'm just kidding. I'm just kidding. You guys should know that, though. So confidence. So you, Borfil. So you get to as a person who is a steward of the data stewards or the data custodians, right? That sounds much more like you're cleaning up crap, which is more accurate. We do things at the behest of the owner of the data. So the owner sets the labels and the who's allowed to see it, and then we, as stewards of data, keep the system secure in a way as defined by policies and procedures and standards within an organization, right? There's all these things. Yeah, one does not simply grant administrator access. What I was just saying, as Control Byte said, one does not simply grant administrator access. I said if you give people in your organization root, you will never control those systems again. You will never get them back. You will never get control of them back. Guys, you know what? It's funny. Like if you ever tell me like, hey, that scene was really, really good in the Lord of the Rings right at the end of the first movie where Boromir falls, right? I'm going to tell you right now, it was better in the book. And I'm not saying that to be like some Chad. I read the books like 11 times as a kid. I read through those books like more than once a year. I loved them. And that is still one of my favorite scenes in all of reading, and I have read thousands of books in my life. I'm a very avid and voracious reader, if you guys didn't know that about me. But anyways, yep. It was well done. Don't get me wrong; it was very well done. But it still couldn't do it justice. So, all right. Confidentiality is who can see the data, whose eyes can touch the data even once. And we joke around about it with, hey, if you don't keep your system secure, a data breach is really just free online backups. And it's true. A data breach is just free online backups forever. You'll never have a problem. Like if Reddit ever wants, not Reddit, Reddit's been breached, but Twitch ever wants to go back and get all their data from who they paid out from like 2020 to like 2022 or whenever that thing happened, they've got it all. It was breached. It's backed up. You can go get, it's like 140 something gigs. You can go download it right now if you want, right? We can know, we have the whole dumps of their database. We know everything. But that's a confidentiality breach. Integrity is that the data are not modified in the time between the sender transmitting them and when the receiver picks them up, or from the time you put them down until you pick them up again. Some of us work in places, I don't do a lot of this. I build a lot of supercomputers for a lot of reasons, but I don't care what the reasons are. And that's actually a very nice thing. Hey, over on the YouTube side, Izzat and Mohammed, hopefully this stuff's useful to you guys. Where I'm going with that is some of you guys, you work in industries where you have to keep data for 7 years. That data needs to be created, used, stored, archived, and then dispositioned and reduced in whatever way that we do it. So, hold on a second. The wife's messaging me. I-17 in Glendale. Jeez, what's she doing way over there? Hold on, I gotta figure out what I want to eat for food, guys, because she said she'll stop somewhere. Let's think. What for dinner? What would you guys eat for dinner? What would you guys eat for dinner? Oh, I might have missed something over on the Twitch side because that big old spam. I do build supercomputers. That's what I do. Yep. The high performance compute, SC. There's all kinds of different acronyms for them. What do I want to eat? The wife will stop somewhere. I typically just send the wife through a drive-through. I don't want her to have to get out unless she wants to. You guys give me some ideas. I don't have any good ideas for food. All right. Integrity. Who can change the data? And this is a big thing that most people probably don't think about with integrity, but is the data the same 1 year after it was last touched? Meaning, entropy and the passage of time, if it can affect your data has had a security incident around integrity, even if nobody maliciously did anything. I want you guys to think about this. We are up to, hold on. Let's go look so I'm not lying to you guys. LTO Wikipedia. I'm just going to go to LTO, and it's the Linear Tape Open Standard. If you guys have never seen this, LTO tapes are still used. They are the exact same size, and they are up to, right now, LTO 9 was released, and that one of these little tapes can hold 18 terabytes uncompressed, and compressed capacity can be 45 terabytes of data. Yeah, but I want you guys to think about this, because I've seen this happen. You've been moving forward, and you started back, maybe your organization for the last 14 years, 15 years now, has been using LTO4, and you've been moving forward tapes, and you've been, every 3 years, as you should with hardware, you've been dispositioning and moving out and destroying old hardware and pulling it out of your racks and all this stuff. And then somebody opens up a box, and it's a bunch of old LTO4 tapes, and you're an audit company, and you have to have this data from... Maybe you have an industry standard or a government regulation that says 20 years. And you've got data on these LTO4 tapes, but the devices you have can only manage LTO 7, 8, and 9. Now you got to go spend a bunch of money and either buy some piece of equipment or pay somebody that kept that equipment to go and load that data up. Probably need to have a good, you probably have to have a real good contract with them for non-disclosure, because now they're looking at data that you don't even know what's on there, and then you're trusting them to not look at it and package it up and send it to you. So that's all kinds of integrity violations from like a standpoint. You don't want to be in that state. So even though a lot of us, hold on. Okay. All right. So integrity, right? And that's an integrity problem. And then moving your data around and making sure that you have a file system that deals with integrity checks, so that things don't things don't just have problems, or you just lose. Oh man, there's all kinds of ways that we deal with this, right? But basically, integrity is that data are not changed unless the people who are supposed to change them. And it can be malicious. Again, somebody messes with your data. That's what the old viruses are. The original viruses tended to not be for anything but the lulls, and the lulls were making people redo work, right? LOLS. Somebody went, Heather, you went to Popeyes? Nice. Shawarma's good. We like shawarma around here. We have a really good place around here near where I live in Glendale called Wraps and Curry. Oh man, they do. They're a little family-owned Indian restaurant, and they are, man, they do really, really good chicken tikka masala and really good chicken curry. And then you can get them in wraps, but I typically just get them with the what's that, the bread and the basmati rice, which is all good. Anyways, okay. And what's our last piece? Availability, right? Data are accessible to the intended recipient when needed, meaning the sender is accountable for successful delivery of the data. Yeah, Control Byte. Thanks for thanks for coming by. I appreciate you. I appreciate your help with labs and just kind of hanging out and keeping people motivated. It's all good. Good recipe for baked little chickens. Nice. So availability, right? Data are accessible. So we deal with availability typically in a percentile fashion. We deal with what we call the 4 and 5 and 7 and 11 nines. There's all these nines, right? And we try to get to 100% of uptime. But we have a whole bunch of different types of nines that we do. And you can go, there's a really good chart on, actually I might even have the chart right here available. Hold on. It's in my security primer. Hold on, I'll put it right here for a second. In my security primer, I have this. Where is it? It's up here somewhere. Ah, here it is. Here are the nines, right? And these are the ones that you can go find this on what's it called if you wanted to, on Wikipedia. But 3 nines is downtime per year, 8.77 hours. That's a pretty small amount of downtime. But then you start talking 4 nines. That's under an hour in a year of downtime. The one that I tend to do or deal with the most is actually not even on here. The one that I tend to see the most from like a government standpoint is a 98.5, but then but then there's 2 of them. So when you have 2 98.5, that somewhere around like a 5-day downtime tends to never be within the same sliding window of the other side of the other downtime. All right. Oh, hold on real quick. I gotta send one quick message to the wife. Oh, she already knew. All right, good. All right, so this is a thing, right? Is the system available for use at all the times that it should be? Now, you can take scheduled downtime, and it doesn't count against your uptime. However, that is still downtime to your customer. So then what we tend to do is start to use things like reverse proxies, which most people just consider load balancers, and we start to not show our customers any downtime if we can. And that's really the standard, right? Nowadays, like, we don't want to take any downtime on our production facing systems. And that's huge. Oh, non, that's exactly what it is, Beelbin. Yeah, non. I don't know why in all this world I couldn't remember that it's non. Yeah, that's my, like, that's the bread. Naan. All right, so we got this. Defense in depth, guys. If we're talking in the cloud, we no longer have the physical security. If we're not in the cloud, you do have to lock your stuff up. You got to lock the doors to your home. Probably got to lock up your cars depending on where you live. And yeah, you have physical security of your stuff. But if you're in the cloud, you don't have a perimeter anymore. Your perimeter is actually the thing underneath there, your identity and access. How you configure the device and who you give access to and how well you keep those keys from other people seeing them is like the biggest part of that kind of security. Is to simulate the adversary's every move. Sure, Freedom, yeah. I mean, people, you know, you can do, there's all kinds of things to do. And actually, this is a part of my, I think I've told you guys, this part of my doctoral dissertation is on, you know, what is actually effective from a business standpoint for security. And you guys might not think about this, but I think about this a lot. There's 29 states in the U.S. that have what's called a stand your ground law. And what is stand your ground? Stand your ground means if somebody starts pushing you around, you don't have to leave. You can stand your ground and be like, hey, you push me again, it's probably not going to go well for you, right? Anyways, where I'm going with that is you don't have any defense in the cybersecurity sense. I just mentioned that to tell you guys that, like, physically you have certain rules that protect you or allow you to do certain things. But in the technical space, if I go right here, I'm going to show you guys this. I'm going to pull this up right here. I'm going to go right here. Let's see if we can, nope. We'll go to Ranger Cam. Ranger Cam typically gets us there. How's Ranger doing? Ranger's doing all right. And then we'll go right here. Strip this off and go 8. And we'll go to our logs here. And let's just say right now, and I've mentioned this before, but since we're talking defense in depth, I'll tell it again. I look, somebody's really coming at my network hard right here. Whoever this is from 118, 194, 231, 208, whoever this is, they're really coming at my network hard. They probably got themselves locked out forever. Well, am I allowed to take this IP address right here and just start attacking them back right now? I want you guys to think about this. From a legal standpoint, do I have any right, if I'm a business, if I'm Google, and somebody from 118, 194, 231, 208 starts attacking me, do I get to turn all the resource, like does like Twitter or Facebook, do they get to turn all their considerable resources upon this and crush them into the ground for attacking them? Do they? No, they can make a report. That's true. You can report things. There's a lot of ways to report things. But they can't. No, you'll immediately get in trouble. You are immediately breaking the law as soon as you take this out right here and run an Nmap on it. You're breaking the law already. You have no right to defend yourself, guys. Yep. Yeah. You have no right. I mean, because watch. Let's say I do that, and then I just go crush this IP address into oblivion, and it never comes back, right? I go pay somebody on the dark web with 50,000 bots to just destroy this thing, right? And you can do that, guys. There's services that do that. You can go buy them right now. But I just want to tell you, that's probably some grandma in, like, Ohio. I don't necessarily like Ohio, but good. Some grandma out there who got her box compromised. That's not her. Yeah, Freedom. When you do this stuff, in your own system and you simulate it, you can do whatever you want. But the moment you turn that on them, I'm telling you right now, you will get a cybercrime. I'm just telling you guys, it's not good. There's no way to offensively protect yourself. So what do? We come in here like this, and I wish I had. Hold on, let me see if I can find. Just let me see if I can find one of these. Hold on, I'm pulling this thing up over here. I need a GIF of this. Hold on. Can I find I need a GIF that's running. Hold on. Images, GIF. Who's got one? There we go. That's a pretty good one. Weak punch. I want a weak punch gift. Or GIF. How's that? Those are some pretty weak punches, right? Super weak punches. Where I'm going with that is we do this to ourselves. And this is what we do with red teaming. And I'm telling you right now, guys, go look at like what a red team's allowed to do. Get into like red teaming and then watch what you're allowed to do and how much you have to plan before you don't actually get to do anything. I guarantee you it's nothing like the real hits that you get from outside your organization, from real people trying to get into your system. But if no one approves, I'm telling you right now, you'll get in trouble every time. Yeah, you can lock down all you want. You can slow them down. You can slow people down with honeypots and honey nets if you want. But even that, it's like, well, how effective is that versus just doing other things? And I would challenge people, look at how the cloud providers, the big cloud providers like AWS and Azure, what do they tell people to do? They tell people to lock their doors really good and then use SIEM and SOAR solutions. SIEM is your security information and event monitoring, and SOAR is your security orchestration and remediation. And you say, well, how do you know that's what they tell you to do? Because as soon as you go take one of their security certs, the first thing they have you doing is looking at logs, how things are coming in, and then automating how they go and get sent out and remediated. So there you go. All right, there you go. Need crossbar over chaos engineering, red teaming. Yeah. If you can't get downtime, make downtime. That's chaos engineering, right? I love it. All right, so identity and access management, and then you've got the perimeter of your system. You've got your network, this seems weird, but the perimeter is like the outside to inside connections, sometimes DMZ type stuff. Your network is your internal network, and how do you secure that? That tends to be with only allowing things to talk as they should with like zero trust type measures. That book that I showed you guys earlier from Solving the Bottom Turtle. I'll pull that up again for you guys in case some of you are like, oh, what the heck's he talking about? I just got here. There's this book. It's free. You can go download it and you can read all you want on systems zero trust security. It's a very common, very popular thing in the industry, and it's good to understand how that stuff works. Even if you're not going to be a security person, you still have to understand security, guys. This is our life. We no longer have control. Yeah. So then perimeter and the network, then compute. This is going to deal a lot with securing compute. This talk. How do we protect the compute, the machines that we're protecting, right? The application, guys, I don't know the application that well. I support the application all the time. I'm always the guy. I think I've told you guys. I used to work at AAA and I was the platform engineering lead for all of the Linux and Windows for the company. And I had about 200 dev teams that wrote apps that ran on our systems, on our servers. We had at any given time about 5,000 machines, which were about 3,500 Windows and about 1,500 Linux. That's probably changed over time, but that's about what it was when I was there. And then at the end, our tasty data. Our data needs to be protected. We need to always protect our data. If you can compromise all the way down and get to my data, it better just be a lump of just useless crap for you. Even if somebody comes in and does a very common type of attack called ransomware, where they encrypt this data further, at least they never got their hands on it to go sell the data. Because those are the two prongs of a ransomware attack. One is they threaten to sell your data or share it to others. They compromise the confidentiality of it. And two, the one that they will still get if you're not careful, is they will damage the integrity of your data. And the integrity of your data does not mean that if they damage your data but could never read it to sell it to somebody, that's only one problem as opposed to having two problems. And then we protect data in transit. As we send the data are protected by HTTPS at layer 7 and TLS at layer 4. HTTPS deals with non-repudiation and making sure that we're talking to who we should be talking to. And then TLS is layer 4, which is dealing with the actual encryption of data and building transport layer security so that you're only talking to who you expect to talk to. That's part of it, just like HTTPS. But then the other part of this is it also uses symmetric key encryption after it identifies the other side, and then uses symmetric key encryption to send data. All right? So there we go. So how do we access the cloud? Remember I told you guys earlier we were going to talk about how we access the cloud? Everything you do in the cloud is based on an API call. Whether you go for console access, you know, you log into AWS or Google Cloud Platform and you get into a console and it's like a little menu in there. You just click on a button and say, I would like to deploy a server right now. And it deploys a server for you. And they're like, that will be 14 cents an hour, sir. Or it's a free 750 hours a month, which is just over the number of hours that could be in a month. And they give you that for like a year. And then you get just free, you can have one little web server running or one little thing. But that's all console access. You're just sitting in there pushing buttons, clicking things. You tend to use a username and password sometimes. And it's best practice to set up MFA if you're using like a root account. And then once you set up MFA on your root account, you make other accounts and you never use the root account again, right? This is all basic security stuff. But you should set complexity requirements so that people will at least have basic entropy of their password that extends longer than whatever the changing time on their password is. You know, if the password's going to change every 4 months or whatever, then the complexity of the password should be such that if somebody were to compromise it and try to brute force it, it would take less than, or more than in that case, 4 months to compromise the password, right? SDK, software development kits. You access via an access and a secret key pair. Typically you have that and then you connect up to whatever. And then there's also command line tools. There's PowerShell tools. There's Bodo 3, which is one of the Python libraries for accessing AWS and that kind of stuff. And then you can access those with access and secret key pairs. Now, the thing about these that get most people is people will put them into their GitHub repositories. This happens all the time. And I don't know if any of you guys have ever read, but from the time that you make a commit or make a new commit to GitHub to the time that that's been scraped, what do you guys think that time is? Do you think that's under 5 minutes or over 5 minutes? From the time that you've made a new commit to a public repository to the time that it's been scraped by somebody, do you think that's over 5 minutes or under 5 minutes? Isobu, it might not be 30 seconds, but it's definitely under 5 minutes, yes. There's a lot of good data on that that's out there. A lot of good data that can tell you about that. It's under 5 minutes for sure. And here's the thing that most people don't know, or this is a thing that people that are casuals about it don't know, is that if you've ever had your access and secret key pairs in any of your commits, and then you later put them into an ignore and send them up, do you guys know if they are still in that history of Git commits, or have they been removed? Because what are people scanning for? The obvious stuff? They're all still there. They're layers down, but they're there. Oh, yeah. If they've ever touched, if the key pairs are ever there, and you don't know how to prune that, that's probably going to make it and get exposed. So this is one of the reasons a lot of companies will have requirements where they'll have a few requirements. One, for not losing data, you won't save anything on your laptop overnight. Most people will have like a commit within 30 minutes rule or something like that. Different engineers have different things like that. And another one is you will probably not professionally be using public. I mean, almost never will you be using public for your professional type stuff. But you might. Yeah. You will not get it. Oh, if you've committed them up to GitHub, you're going to have somebody else do it. But I'm talking about just in your local forks and stuff. You're going to they will be in there if you don't know how to prune that. So look, unless you want to go really, really get good at Git, you need to be careful with this stuff. And I hear about it all the time. And look, I do a lot of contract work. It's almost always contractors that do this shit. It's very rarely people in your organization. But, it doesn't matter. I tell you guys all the time, does it actually matter if it's malicious or not? Maybe a little bit, but it doesn't stop it from being an unmalicious leak is still a leak that still costs your organization X amount of money. All right. Here's a shared responsibility model. This comes directly from AWS. You have to understand this well if you're going to go get like a security certification. I know I don't know if Fisherman's around still, but myself and Fisherman, we both have AWS security certs, right? And that's the AWS security specialty. I got to decide if I'm going to retake it again because mine expires in, I think, January, right in the middle of January. Still fishing around. Yep. But look, the way this works, this breaks down to, I have another slide sometimes that I'll use, but this is your decisions up here and AWS's decisions down here. So it's an abstraction layer that you don't need to know about. But down here, I want you guys to think about like this. Do you even know where the availability zones and where all the regions end and where all the edge locations are for AWS? And if anybody other than Fisherman tells me yes, I'm going to tell you you're lying. You might know where one of them is, but I guarantee you don't know where any good majority of them, even if you work in this space all the time. You're not going to know that. But AWS knows that, like they should, and they keep that stuff updated. Did you know that things within an availability zones tend to be 100 kilometers or more from each other? They've got standards for all of this stuff, how they determine all this. Edge locations are almost never owned by them, but they're highly contractualized organizations that work with AWS to provide exactly the services that they want to be in edge locations, which is if you're going to be like using some type of Amazon, almost like a co-location. What's the name of that tool? Not AWS Outposts, although you can do outposts in them. AWS, God, why can't I think of that? Anyways, so they're going to update all their infrastructure. You don't know what level of their iOS their switches are at and all that kind of stuff. You don't know any of that. Then the big four, compute, storage, database, and networking. These are the big four of the cloud. They're going to update the underlying firecracker. You don't need to know what's going on there. Storage, they're going to update the back-end storage, and they're going to keep adding more and more pieces on that. You don't have to you don't have to do any of that stuff. Database, you don't have to worry about what version of database is underneath the hood of Athena, that kind of stuff. That's not for you. And networking, you don't have to worry about how the networking happens between these different infrastructure pieces. That being said, they also update their software and all that. Now you load your data. You always load your data. Nobody ever loads the data. I tell you guys all the time, if my company got popped tonight and all our stuff was leaked and everything we do was leaked and all that, what you would find is nobody would go on the news and say Redline and AWS lost all your data. Oh, hell no. They don't care about that. They go, hey, you lost customer data. Redline lost customer data. Oh, jeez. Down here, what I said earlier, you don't have control of the physical access anymore. You don't even know where it is. But the physical access is now, for you, access to your system is all around identity and access management. It's one of the reasons that if you talk to anybody from AWS, you engage one of their technical account managers or their solutions architect people, they're going to be so keen on making sure that you understand the security aspect of it. Gosh. Look, check this out. You can spin up all the operating systems you want. You can stand up network connections and allow things in. You can build firewalls, and then you can expose those firewalls, and then you can lock those firewalls down. But this is all dependent on you. If you spin up a RHEL 8 box today, hell, go back to CentOS. You're on CentOS 7, and you just never update it. So you're on CentOS 7, you never update it, but you leave it completely open for anybody to connect to, then that's on you, guys. That's not on them. How the hell is that on them? You're the one who spun up an old OS, left it running, went and put the private key everywhere in the world so everybody could connect to it. That's not on them. That's on you. All right. They give you client-side data encryption and data integrity authentication. They give you free certificates through their certificate manager. They just generate them for you. You used to have to pay thousands of dollars for those like 15 years ago. Nowadays, there's so many free tools for it that there's not really a market there, so they give it to you. But if you don't turn it on and set it up, that's on you. So this is on by default now. This used to be, you used to have to turn this on with S3. Now S3 has server-side encryption on all the time. But it used to be something you had to choose. And if you didn't choose it, well, whose fault is it if you lose your data? Right? And then network traffic protection, encryption, integrity, identity. All these things are kept behind PKI infrastructure, which is your public key infrastructure. And you deals with if you understand how your certificates work. So we're going to talk about certs in a second here. But anyways, all these pieces, shared responsibility. All right, so data security. How does data security work? And this is kind of focused on the cloud. I didn't call this compute in the cloud, like specifically as a talk, but it's kind of cloud-based. Also, I think the wife's home, so I might be eating here in a second. All right. So where do we protect data? We do protection of data at rest, on a device or in the cloud, data in a file storage, block storage, and object storage. By the way, if you take these three right here, and if you say, Scott, I don't know cloud very well, and I said, that's fine. Go look up the difference. Go do a little write-up. Put it in my Discord. Do a little write-up. This is like a college lesson for you. Go write up the how these are similar and how they are different. I don't know what that was. DIFF. How are they similar and how are they different? There's a little college level assignment for you guys. You guys are like, oh, you know, Scott says he's a college professor, but he never makes me do anything. Okay. Go look up how file storage works, how block storage works, and how object storage works in the cloud. By the way, if you can talk to each of those for about a minute, you're probably fine. Probably do fine on an interview, probably do fine explaining it and talking about where we would use it. But yeah, how are they similar? How are they different? And then when you compare and contrast things like that, kind of like if you remember, you know, Sesame Street as a kid, one of these things is not like the others. One, you know, they had that little song. Well, sometimes it informs us because then I can say, okay, well, block storage makes sense when I'm attaching it to some type of compute. File storage makes sense when I am going to share something across multiple file systems or maybe multiple systems that need to connect to it. And then object storage is like I need to be able to pull something and access it through an API. And you could talk to each of those different pieces, right? So our data at rest is when our data is sitting there, we are protecting it in some way. We implement envelope encryption where a data key is used. And then we encrypt that key with a separate key. And then we sit right next to that. The key can sit right next to the data on the storage on whatever tool we're using, and it'll all work. All right. Hold on real quick. I got to let the wife know that, oh, I'm free. All right, guys, I'm going to take a quick break here. Let me go put, let's see where's Ranger at? I don't know where Ranger went. All right. I'm going to put a little hourglass up. I'm going to say, whoops, where's my hourglass? Not 45 minutes. But you guys got an assignment. So, quick break and food. And we'll say 10 minutes. I'll take a 10-minute break. I'll be right back. Let's see. Fisherman's in charge. Alright guys, back. The wife's gonna come sit by me and we're gonna eat. And I'm gonna tell you guys stories. And tell you guys stories about stuff. And the wife's gonna sit here. She is the senior IT person in this house. Oh. Yes, she is. And I'm gonna tell you guys all about it. I'm gonna make her tell you guys a story. Do you guys want to hear? Here, we'll ask the wife. Hold on, we'll pull it up. Hold on. She brought me food. Hold on, I'm gonna pull this up for you guys. You can't see that stuff. Can't see that stuff. Notes on engineering. Don't worry about that. That's something else. I think it's way over here to the left. It's one of... here's our questions for our guests. So Julie's going to be... The wife is going to be our guest. And I'm going to ask her these questions. And she's going to answer them in between stuffing food in her mouth by me. How's that sound? Does that sound good for you guys? I'll turn off my hourglass for now. All right. If you guys have any questions for... You can ask, like, how does she put up with me? And all that stuff. Ooh, this is good. All right. So the first question for the wife is, what is your basic role at work? And you don't have to tell them where you work. Don't tell them where you work. They'll try to dox you.
My basic role?
Yeah, what do you do?
Network accounts, reset passwords. I've had no training. I'm a trained monkey. I do what they tell me.
What's your title? She's a help desk. She won't tell you. She works help desk.
Yeah, help desk analyst, but I hate that title because I very rarely can be helpful.
She said it, not me. Oh, Freedom wants to know, can you give suggestions to be good with customers?
If you can, put them on hold. Because honestly and truly, when I put people on hold, 80% of the time their issue gets resolved. Like,
that's good engineering right there.
They're either, now that they've got a person on the phone, they're calm enough to actually do troubleshooting. It's wild. It's crazy how much that helps. It doesn't sound like it's very nice, but especially if they're talking over me, I'm like, okay, go ahead and hold. And then I go back and they're like, oh, you know what? Never mind. It's working now. Or I figured it out. Or whatever.
All right, so I'm going to tell the wife something that I don't think she knows, but she's going to start using this now. So, Julie, some help desks in IT, they have like a little monkey sitting there, or they have like an elephant or something, like a little stuffed toy. And you guys should put this on like wherever your help desk page is for the school district. And it goes like this. They have to explain the problem to the monkey. And almost always people go, oh, wait a minute. And then it fixes their own problem. I actually saw this at a school one time, at a college. Before you could talk to somebody, you had to come in and explain the problem to the monkey, because you would almost always find, oh shoot, that's what I did wrong, and then you'd walk out. And they found that like their number of actual tickets dropped huge. So yeah, Rubber Duck, that's like a programming thing. They explain their problems to Rubber Ducky. So you'll see programmers with like a Rubber Ducky on their desk. All right, guys, so the wife's gonna say, okay, what roles have you had over time? Julie has been a help desk person since before I got out of the Army. So how long have you been help desk?
As of August 3rd, 21 years.
Oh my gosh. A long time, guys. Ask her anything. She knows help desking real well.
Well, when was the last time you restarted your computer? That's about
it.
That's about it.
These teachers have problems, and she's there to solve them.
Currently, right now, my issue is multi-factor authentication. It's a thorn in my side.
Good old multi-factor authentication. People think it's a silver bullet. It's only part of security, though, and they still get compromised. There's been some pretty interesting compromises. Uber got hit really hard in the last few years. You heard about that, didn't you? No, she didn't hear about it. Okay. What training have you had, and what impacted your career the most? Besides meeting me there and working with me and loving me and all that stuff.
That's literally what's impacted my life the most. I really had no training. Well, actually, I worked for AmeriQuest Airlines prior to working at the school district. And that was like, what is it, a CRC, a customer service, or maybe, I don't know what it is, customer.
She dealt with customers. Always
CSR,
customers.
So I think that helped. And then, yeah.
How jealous are you of me that I get to work from home and go to nap all the time?
I'm envious of the napping. When I'm done working in 5 years and 7 months, I will nap then during the day.
You heard it from her. Naps during the day. Hot take. All right. We'll skip some of these. How many meetings do you have a week? Do you have a lot of meetings?
I probably have one department meeting every 2 weeks.
Oh, Fisherman had a good one. Fisherman's the one that's always mean to me, by the way.
Okay.
Yeah, so he's the one, like, when you hear me crying myself to sleep on my pillow, it's typically because of things Fisherman's done to me. Okay, Fisherman said, has she considered any other roles in IT?
No, not really. I did apply for the help desk 2 position, and they were kind of like, do we want someone with personable skills or do we want someone with technical skills? And they ended up hiring the person with technical skills, and after 8 months of this person having to talk to people on the phone, they just moved her over to a LAN 2 position, and then we lost our help desk 2 position, so that made me angry. And then when my supervisor left in 2018, I applied for her job, and they gave it to the person that did there a few months. Maybe it's my attitude. I don't know.
It's definitely being late to work every day.
Hey. Back in 2018, I wasn't late every day.
I love my wife.
Ever since I haven't had a supervisor,
She hasn't
really
been.
cares when I go to work.
She hasn't been to work on time once in those 21 years.
That's not true. I got written up.
She's done
and
it
then
twice.
I was on time for like 2.5 years, and then no one cares.
It's brutal, guys.
Anyways.
She sometimes comes in and scares me like 20 minutes after the hour, and I'm like, oh, God, you're still here? And I thought she had left for work already. It's crazy. She likes scaring me. Okay. What's something interesting? What's an important skill to get into the help desk? What do you think is an important skill? Having no skills is a skill.
That is true, but
You have skills.
But I also feel like just being able to talk to people, really. I mean,
This is Julie.
There's a young kid that I just wanted him to answer the phone one day, and it was like I'd asked him to, jump in with the alligator. He was petrified.
You see the Saitama up there? They see it. It doesn't pop up over here, but it says that you're just a hero for fun.
Yes, that's true. That's exactly what I am.
Look, I also have this one. I say, I can answer that for money.
Yeah, I don't really care about that.
You don't care about the money? You don't do the school district stuff for money?
Lately, it's been pretty funny because technology's almost afraid of me. It's become like a joke. People are like, this isn't working, and they'll be like, oh, have Julie come over here. Technology's afraid of me. It just stops working, or it just starts working when I come around.
She's actually the senior IT person in the household.
Oh.
Because I was still in the infantry when she was doing school district stuff. So while I've gone off and been an engineer for almost 20 years, she's been holding down the help desk. And she's got a really nice purple mechanical keyboard.
Oh my gosh, I love my keyboard. It's amazing. The only thing I had to get used to was it's a compressed keyboard, so the arrow keys are embedded into the keypad. So that's taken a little bit to get used to, and I have to click my function to delete. But other than that, I absolutely love it. It's amazing.
Is it this mode?
No, it's a red.
Hold on, let's see if we can find it over here. Can you find it? Is it one of these?
No. I forget what it's called. It's like...
It's got some brand name.
No, what's...
Is it like this one? The
Yes.
NuFi Halo?
I can't remember. It is pretty amazing, and everyone is very excited when they see my keyboard.
It's kind of like that one. Kind of looks a little. This one looks a little sillier than hers, but it kind of looks like this one.
Oh yeah, but that doesn't have a number pad on the side.
Oh, you need to have a number pad. Oh yeah, the wife is a big fan of. I'll turn off that. A good keyboard, and it's nice click and clacky. And then I get her those things that sit underneath, like so your wrists and your everything are real nice and feel real good.
Yeah, that's been real nice.
She likes that. What are you currently listening to? My wife listens to so many books. She's in 2 book clubs, and she listens to quite a few books on...
I actually am obsessed with audiobooks. Right now I'm listening to Hamilton. It's amazing. If I get through it, it'll be the longest book I've ever listened to, 39 hours.
Oh, wow. You ever going to read Shogun by James Clavell?
Probably not.
That's on Hulu. I read that in high school. I did a report on that in high school. It's 1,176 pages. They put an extra 1 on the end of that. It's 1,100. And 76. What speed do you listen on, Julie?
Well, it depends on how, like with Hamilton, I've got it at 1.25 just because there's a lot of characters. I usually start off most books at 1.5. If I'm getting scared or nervous, I bump it up to 175. If I can't stand the person's voice or I'm hurrying to get through it, it's at 2.
It's super funny that she said she gets scared because, like, I literally scare her every night because she forgets that she lives with somebody. So, like, I'll reach over in in bed, and she'll be like, "Ah,
Who is this?"
Very scared of cat.
Someone wanted to see a picture. Do you want me to send you one of mine?
Yeah, send it over to me. I'll put it.
Email?
No, just text, and I'll put it in Discord.
Okay.
All right, guys, I'll put that up in Discord under like Home Labs or something. Wait, no, Fisherman had a question. Fisherman said, he said I make so much money being a YouTube sensation that she just does it for fun. Yeah, you don't.
I really do my job for fun.
She doesn't have to work.
And honestly and truly, I really am only busy in like 2 or 3 weeks in July and 2 or 3 weeks in August. And then it's like working on puzzles and doing my nails during the day, so.
Yeah, because school districts aren't super bad. Except for right at the beginning of the school year. And right after Christmas break, right?
Yes.
Those are the 2 times. Okay.
I mean...
Wait, the wife's sending me the image. Hold on, I'll put it on Discord and then I'll pull it up.
Another tip I have for everyone is just don't piss off the help desk. Because I really have a...
She's got Active Directory.
I have like 3 or 4 people that I refuse to answer the phone for when I see their names come up. I will procrastinate doing things for people that have been rude to me, but I can. And there was a teacher one time who at a board meeting said that support staff wasn't necessary. Yeah, I hardly do anything for that guy.
He said support staff wasn't necessary. And you should have said super necessary. All right, hold on, guys. I'm going to pull this up here. So, over here. This is the picture she sent me. Where's our home lab? Home lab. This is what she sent me right here. That's her desk.
That doesn't have my new... Scott recently got me a new pad for my wrist. And I only use that pad, the lavender one. I only use that one when when it's super busy.
She likes butterflies, guys. We have that keyboard is very clickety clacky. I remember when she got it. Very clicky clacky. Ah.
Ooh, yes, I love it. And right now, one of our the guy that's redoing a bunch of switches, he likes to just pull all the cables out and make like a mound of cables. And someone was frustrated in the... I should have taken a picture of that, but someone was frustrated that the cables were all knotted up. So right before it got super busy, I tangled all the cables. So now they're strewn all over my desk, like according to size. And now people can just come and grab them, and they love it. And I really have felt appreciated for just untangling cables.
Johnny, man, we are sitting here. My wife brought me some food. So we are hanging out, and she was showing us her desk and telling us about being in the help desk. By the way, real quick, guys, if you guys want to go back and watch any of the things from this weekend, if you missed it, we have some talks from Sending Grounds, M-Pesa. He talked about eBPF. And then Fisherman, who's in here trolling me now, you guys can go troll him on his YouTube. Anyways, they were all really good talks, and they were really good technical talks from guys who understand the industry well. And then, Wifey, what type of side projects do you do? You can tell them about your
I love to
scrapbooking
scrapbook. That's my all-time favorite thing.
and your
to do.
voice acting stuff.
I haven't done that as much as I should, but I like to scrapbook, and I like to travel.
She does like to travel. She's trying to hit, what, you got like 8 more states to hit all 50?
Yeah, I want to get to all 50 states before I turn 50. So I've got 2 years and a couple months, and I have 10 states left. I'll get 6.
Don't tell
in
him how
October.
old you are. She's 24.
I don't think, sweetheart.
She's 24, guys. Gosh. Don't tell me you're 50.
Well, I'm not 50 yet.
Don't tell me you're almost 50.
Yes, I'm 18 at heart, and I'm the favorite aunt.
Oh, why didn't I do a wife session? Because you were busy all week. One of her friends got married. Oh, man. She could tell you. You guys want story time. She'll tell you. No, this is going on YouTube.
Yeah, no.
The long and short of it is her friend just married a guy who had been married 17 years, and he got a divorce like 2 months ago.
In April.
Yep. Okay. 4 months ago. And he's got 5 kids, and she married in. She has no kids, and she's moving to like Minnesota.
She already moved to Missouri.
Missouri. It's the same thing. I think it's going to be crazy. Oh, gosh. Control Bite, you do not want to know that. Who's more competitive in games? Her family would slit each other's throats and watch them bleed out to win a game.
No.
Her family is the most cutthroat group of.
We
her
grew up
her
with a
dad.
dad. Like if you won,
Her dad?
you know you earned it.
Her dad is well, he's almost 80, right?
No, he's 75.
He's like 74, and he will crush the grandkids. He will crush his grandkids and stand over them laughing. And like we have this thing in our game room that says no crying and no cheating, and he'll like point at the thing and be like no crying in the game room. He crushes them. They are way more competitive than me. That being said, I'm also very competitive. Yeah, I like playing games where you work together. I like, have you guys ever played the game
Castle Panic.
Castle Panic? That's one of my favorites. Alright, so the wife does side projects. We'll get back here. She's going to sit in here with me, and we're going to keep munching on food.
And I'll listen to Hamilton.
And she'll listen to Hamilton. I'm not going to keep telling you guys stories. But if you guys think of more questions for her, I'll turn around and ask her. She's going to sit on this big beanbag chair I have in here for her. Basically, it's just so that she sits by me. Curie Bloodrose, raiding with a party of 1. How's it going? We are doing system stuff. Hopefully this stuff's useful to you. Hopefully this is useful to all of you over on YouTube. You guys know we got Discord you can hang out in. We've got almost 24... What do we got? Almost 2,400 people over there. They're attacking all the data. That's fair enough, Kiri. Yes. Quartz 1 with the resubscription. I appreciate that. Yeah, I try to,
1 year with this awesome community. Thanks for everything.
Thank you for that, Quartz. I was very surprised that just talked because my sounds have been so busted that I don't even know when it's going to talk or not. So, but I appreciate that. Keeps me motivated. Guys, we're back over here. I asked you earlier, and again, if you want to make a difference, when I say make a difference, like make a difference for yourself. Think about this. How does file, block, and object storage interact? How does it deal with these different components we were just talking about up here? Compute, storage, database, and networking. how do each of these pieces affect that? Or where are they used at? How are they similar? How are they different? It's something to think about. So then we move down here before the wifey got here. Data in use, right? Data are temporarily stored in memory or be used in calculation by the processor. So data at rest is when data is just sitting there like a lump. What is the dangers to data at rest? Being exposed. We protect that through encryption. Being encrypted further, an integrity attack, somebody doing a ransomware, we protect that by not letting things change our data, and then also keeping air-gapped off-site versions of our data. And I have a whole talk on that we do every now and then. But data in use, we want to keep, even though the data's all being pulled up in memory, we can mask the data so you only get access to certain parts of it. Data masking can be done in the application. It can be done in the loading of the data down to like a lower environment. It can be done in the actual databases nowadays. There's a Redshift database in AWS that data masking is built right into the identity and access management. So there's all these things, right? You can have granular permissions. People don't even know that tables have certain columns in them because you can only show them things that you want to. So there's all kinds of ways to protect our data in use. There's all kinds of different techniques for that. One of them is just don't keep data open. Like if you're not using a file, close it in memory. There's no reason to hold it open. You know, most of the stuff I do is scripting, so I open a file, I write out to it when I'm done. But for people that are having long-running applications and stuff that's being run inside of Kubernetes and pods and all that kind of stuff, your data and use practice is really important to security in your organization, right? And then data in motion, right? The data are moving around. They're being transported between locations. They can be sometimes secured still in an encrypted way, but we're going to use PKI infrastructure to ensure that we're talking to who we think we're talking to. And then we're going to, after we determine that we are talking to who we think we're talking to, we're going to pick an encryption schema and pick a key and do symmetric key encryption between them after we've identified who they are. Now, the initial communication is an asymmetric keying process, but then we agree on and switch to a dynamically generated symmetric key, and I want you to think about why that happens. This is an important thing. You can go look it up. You can go Google it. You can, just sit there and muse on it if you want, or I'll tell you here in a little bit. HTTPS at layer 7 and TLS at layer 4, they ensure that data is encrypted in transit between just 2 points. Nobody in the middle can capture your data, right? All right. So, envelope encryption. It's the practice of encrypting plain text data with a data key, and then encrypting that data key under another key. You can even encrypt the data key, encryption key under another key, and you just keep going down. There's actually a game that keeps showing you how to encrypt further and further. But I want you to think about this. So you have some data, and the data is sitting there open. So you get a data key from somewhere, and then you encrypt your data with it. But then what do you do with the data key? Well, the answer is you encrypt it with another key, an envelope encryption, and then now the data key and the data can sit next to each other on the shelf, but to anybody looking at them, they just look like two lumps of data. They're useless. They're just data sitting there. Then, when somebody checks out your key, in this case, this is the key management service by AWS, right, or KMS, they check out that key because they have permissions to, then they can go decrypt the data key that's sitting next to the data, and then once they've decrypted that data key, now they can get at the tasty data. But you can then give granular permissions over here for who can get access to data keys to get at data. Now, should you still give everybody access to that shelf that's sitting there with the data? No, of course not. But the point is, you can encrypt everything with envelope encryption. That's how it works. That's the minimum cloud standard. Everybody uses encryption like that. Yeah, tasty data as the data, and I'm sitting here munching on Funyuns, right? Tasty data. What was I going to say about this? The minimum encryption standard for the cloud and some of you heard me say this probably 100 times, is AES 256. That's the minimum. AES 256. All right, there you go. This is that data in use from earlier. We mask things. Look, everybody knows that a social security number is a certain number of digits long. It's always the same. It's always that length. What is it, 9 characters? It's always that. So why show it all? We know that it's there. The production database validating that, those things are there can be sitting there, not being shown to everybody. And then when we move stuff to dev and test and analytics and whatever other things we're doing with our data, we don't need to show everybody the whole thing. When you guys talk to somebody on the phone and they're like, hey, just read me the last 4 digits of your credit card or whatever. One of the reasons they do that is because they want to validate that you are who you say you are. But the other one is that's the only 4 digits they're shown. The rest of it's masked like this, because why show anybody my data? Just give them enough to be able to verify that we are who we say we are, right? That's what authentication is, right? In the AAA or quad A schema that people talk about. All right. So data in motion. I'm going to eat more of these Funyuns real quick. You guys sit there and talk amongst yourselves for a second. Actually, think of if you have any more questions for the wife. She's sitting behind me still. Salt and vinegar chips. Hey, do I like salt and vinegar chips?
No. I love them.
She loves them, but I do not like them. Oh, that's a fun one. What's the wife's preferred OS? What's your preferred operating system?
Is this tricky or is this a trick?
What do you like to use for computing?
Windows.
She uses Windows. What's your favorite Linux distro? That's what they said. I'm her favorite Linux distro. Yeah, my wife's over here. Yep. Yeah, if you guys got questions for her, you can ask. She was in here just a little while ago talking about this stuff. She was telling us all about being a help desk person. Hey, Julie, there's a little cat on screen eating food.
I love cats.
A little cat eating munchies there.
I love cats.
It's like a little emoji. All right. Guys, I have moved on to my favorite recent snack, Reese's Pieces. I don't know why I like these so much, but these have been my favorite recently. I have made the wife get me many packages of them over the last few months. When she's getting snacks. Yep, that's what I'm munching on now, guys. All right. So, what did I do? Recently, it's been these little Reese's Pieces. Julie, what's your favorite snack?
Right now, I've been on a kick of the Keebler sugar wafers.
Oh, she likes vanilla sugar wafers. Yeah, she gets those on road trips. And then she'll be feeding them to me. Or like making me munch on them while I'm driving. And I'll be like, these are okay. I mean, these are better than like a car crash, but they're not great. They're alright. Yeah, her favorite snack are those little wafer things right now. Also, fun fact, whereas, well, I don't drink a lot of soda, but when I do, I prefer Coke. She is definitely a Pepsi person.
100%.
She likes Pepsi. Oh. They want to know if you like Arch, Gentoo, or LFS. And that could be Gen 2, but I don't even know what LFS is.
I don't know what those are.
She doesn't know what those are.
What are they?
You should ask her help desk questions. Those are types of Linux.
Oh.
To be fair, they're not very popular types of Linux. By the way, guys, I tell you all the time, I don't care what version you guys use. I think being a hobbyist is part of the fun of doing this. And I will never tell you to, not to use the versions that you like. But I will tell you, when people say, hey, Scott, I want to get professional about this, I will tell you, okay, in the professions, we have to start moving towards these certain versions. Not because we love them, because that's what everybody's paying us to do. And as I was joking around with about Mr. Krabs in my talk the other day, hold on, let me pull this up, because some of you guys missed my talk the other day, and I vowed that I would talk through it one of these days, but it will not be today. But why engineering, right? We're talking about why do we do engineering, and what's, get out of here, that little stupid thing. Why do we do engineering? Hold on, I'm just gonna do this real quick. This is the main reason we go and we learn these things right here. Oh, Linux from scratch. Oh, no, she's probably never built Linux from scratch. But the wife did get me a couple of pillows that have penguins on them. That was kind of nice. I got them in the bedroom. They sit up, kind of like. Never thought I'd have nice pillows like that, but I do. That might be my favorite. Oh, right there. That's why we're engineers. All right. Julie, do you like Rocky Linux? She's not listening.
Do I like it?
I don't know. I've been using it a lot. It's been what's keeping me working lately.
Yep, then I like it.
Good. There, she likes it. I've been doing a fair amount of Rocky Linux professionally. It's more popular last few years than many other operating systems I've used, but by far and away the one that's the most used in government projects and such is still Red Hat. You're probably still going to run into more Red Hat than anything else, guys. So it's one of these things, you know, even though it's IBM, we got to do it. No, I think about which said they're sending. I think about it as like a replacement for CentOS, sure. But the funny thing to me, CentOS. It said scentless shirt, Julie. Silliness. Anyway. Oh my gosh. No, Julie wants to tell you guys a dad joke. Go ahead, tell him.
What has two butts and kills people?
What has two butts and kills people? Somebody tell us what has two butts and kills people.
Can someone get it?
Nobody said it yet.
Can I say it?
You can say it.
An assassin.
An assassin. I've got this calendar downstairs of dad jokes that is mostly just she just does stuff. My favorite dad joke is always going to be, what do you call a beehive with no exits? It's going to be always my all-time favorite dad joke. What do you call a beehive with no exits? Unbelievable. That's funny to me. And if it's not funny to you, I can't help you. All right, guys. We'll get back to this here in a minute. I'm just stuffing candies in my mouth still. They said it's not a competition, Julie, but if it is, you're winning.
Oh, competition for what?
I don't know. They said you're winning.
Yay. I like that.
She likes winning.
I won when I married Scott.
She won when she married me. There you go. You guys heard it directly from her. I didn't make her say that. Oh, our telling jokes on the internet? That's our plan B, Julie. If my tech thing doesn't work out, then I'll just go tell more jokes. Debatable. Fair enough. All right. Guys, so we don't use SSL anymore. SSL's been out since 2017. When I say out, I mean out the window. Don't use it. We use TLS 1.2 and 1.3. How they work is like this. You're going to say hello, and the server's going to respond hello back. That's in TLS 1.2. In TLS 1.3, they get right to the point, and they send you a certificate to verify. So we'll talk about how you get the certificate and what the trust introduction is. But you're going to do a key exchange and determine that that person is who they say they are. We're going to talk about that process here in a second. But we're much more efficient nowadays in that it only takes 5 pieces of communication until we start talking and calculate our symmetric key and have a secure channel. So let's go down. I think it's the next slide. Nope, it's not in the next slide. I don't know why I don't put these next to each other. Let's go jump to how this communication happens. I'm going to go down to right here. So there's a certificate authority out here. What's it? I want you guys to think about this for a second. Don't even think about this like an engineer. Think about this in life. What is an authority? What does it mean to have authority over somebody or something? What is it? Derived authority? Like Sending Grounds did. He told you guys on the other day that he has a degree in religious studies, so he probably has a certain view on what authority is and where authority is derived from. But what is authority? Authority, in some ways, is just someone you choose to trust. Yeah, the government can be an authority. That is true. Yeah. But in this case, an authority is somebody we choose to trust. So a certificate authority is somebody that we choose to trust. Now, you can set up certificate authority. Certain browsers come with authorities already trusted. And Akamai is a big one. Akamai, there, they spelled it right. But anyway, so what happens is somebody in the world wants to be able to prove that they are who they say they are. So they go to a certificate authority and they say, hey, I want you to validate that I am who I say I am. And they say, okay, we'll do that for you. We're going to generate you a key. And the key that they're going to generate, this server certificate, this SSL certificate, is going to be private. The wife does know what Brotato is, yes. Julie, do you like Brotato?
Yes.
Do I play it a lot?
Yes.
Yes, see? I play it a whole bunch.
It's the only thing we play.
It's not the only game I play now, but it is one that I play a lot. But so certificate authority comes down, and you keep a private version of the certificate. Then the public version, they will give to anybody who will ask for it, and they will spread it far and wide. They can throw the public version out in the streets. Doesn't matter. Because how this communication occurs then is going to prove that you are who you say you are. Because only you can have your private key. So with the certificate, there's a private key that comes with it. And you keep that. So when this communication starts between them, the public side over here, this guy's going to say, hey, are you who I think you are? And then they're going to say yes. And they're going to send something encrypted by their private key. It's going to come over here. You're going to decrypt it with the public key and go, that's funny. That's a good joke. And then you're going to send it back. And that's going to prove that that they are who they say they are. That they were able to send you something, and you can even, there's different ways that this authentication works. You could pass something to them and they can send it back to you encrypted, and then you decrypt it, and that proves that they were the only one who could have done it. The person that had the private version of that public key that you have from, again, a certificate authority that you trust. So when you come back up here and you look at this, you went out and you got a public version of Fisherman Guy Bros server. Fisherman Guy Bros server has the private version of that public key that you got, and you said, hey, go ahead and share that key, and they'll send you something encrypted, and you'll decrypt it from the key that only they could have encrypted it, and you'll go, ha, 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 and then you'll say, yeah, that's them, and you send it over, and then that's how the communication occurs. And if you say, well, it can't really be that simple, that's what it is right there. You can go look at the ciphers they use, and you can go do all that stuff if you want. But that's public and private key encryption from that's start to finish how it works. All right. So basic encryption techniques. All encryptions are based on ciphers. We pass plain text through a cipher to get ciphertext through a correct cipher again, using the correct method, and you'll get plain text. This is like, if you guys ever do networking and you learn about the presentation layer of the OSI model, there's three things that happen at the presentation of the layer of the OSI model going down the stack before we send something to the other side. They are encoding, encryption, and compression. Those are the three things that happen at the presentation layer. Encoding, encryption, and compression. Now, when we get to the other side and at the same layer, layer 6, as we're going back up the stack, getting to the user, we do three things to data over there. We do decoding, decompression, and decryption. And some of you are very astute and you go, wait a minute. You just said encoding maps to decoding, and compression maps to decompression, and encryption maps to decryption. And I would say, yes, that's exactly what I just said. That's it. That's all that happens at the presentation layer. And there's all kinds of different protocols that do those things, but that's all that happens there. Well, it's the same thing here. We've got symmetric keys, and in a symmetric key, it's like a decoder ring. I've got a decoder ring, and I want to send to fishermen, hey, let's go fishing on August 10th. And I switch it around with some encryption key that we both have, and then we laugh about whatever, we're going to go fishing and not tell the wives. But with asymmetric encryption, we've got a public and private key pair that are what we call cryptographically related, and only the public key can decrypt something made by the private key, and something encrypted by the public key bit can be decrypted on the other side by the private key. And that's how public and private key pairs work. For SSH, you keep the private key safe, and the server stores the public key to allow as an authorized key for a user. And this is very analogous to a lock in that case, as the public key. And that's in the authorized key file. And then that's how you communicate over SSH. You keep the private thing, you go, and the public key can be stored all over in the world. Like you guys could post it in Discord right now. Your public key, and any of us that wanted to could go put that in our server, and you would have access to the server as that user whenever you wanted. And that's perfectly secure for most of us. I don't care who has my public key. But that private key is never leaving. I'm never going to show it on stream. I'm never going to whatever. We got to rotate it every so often according to NIST 800-57, right? There's all these things. But for TLS, the server holds the private key, and you, the client, can go download the public key from a certificate authority whenever you want. And that's based on trust. So what a certificate authority then is, acts like a third-party trust. I go over to Fisherman's house, and I don't know Fisherman, but I know Robodom, and Robodom's there, and Robodom says, hey, this is Fisherman. And I go, okay, that's Fisherman. I didn't know him. I thought I knew who he was, but until you introduced us, I did not know. But I'm trusting him as an authority on who Fisherman is. Now, look, in day-to-day life, we don't really think like that. Like, oh, I'm trusting this person as an authority. But you are. That's what it is. And then when you think of it like that, it makes the technology side of this super simple. The thing's just acting to introduce us to each other. And once it introduces us to each other, we can only talk to each other and nobody else. That's exactly how HTTPS and TLS work. That's it. But then when we get to that, so this is what we just talked about. HTTPS is mainly there for non-repudiation. I wouldn't talk to anybody else, and you wouldn't be able to say I wasn't talking to you later. That's what it is. That's what non-repudiation is. You can't, there's two things. Non-repudiation proves for your reputation that you are who you say you are. And then it also, you can't back out and say you didn't say something because only you could have done it, because of the fact that you hold a private version of your key. So back to this again. You download a public key, and you send through some method, whatever that is, to the server, and then that server either encrypts or decrypts the string you give it, and then sends it back to you, and then now you can trust that they are who they say they are. Different protocols in that respect work different ways, but it's the same idea however it is. Private key held here on the server, public key spread far and wide for anybody who wants to try to verify that that server is who they say they are. That's it. All right, so compute security. This deals a lot with how we secure compute systems. Compute are just things that are doing processing for us. They are, when we talk about compute in like a high performance compute sense, we're talking about one system that can do a certain amount of work for the cluster at any given time, right? So we plan our subnet placement. Do the subnets need to be able to reach out into the world or not? And that'll determine where we put certain things. Like, does a web server get the same placement as a database server? Think about that. Does a web server get the same placement in our network as a database server? And immediately you're probably like, well, a web server needs to talk to everybody almost without reservation, and the database server doesn't need to be talking to anybody. In fact, the database server should be so locked down that it doesn't even talk to other devices in your network that other people think should be talking to it that you don't think should be talking to it, right? Because, again, why would you share your data from your data owner in your organization with other people and processing and start to worry about service level agreements being broken and all these other things? We need to make sure that we place things the right way. There's other ways to protect that too, and obviously sometimes you just need to go thump somebody on the head in the organization if they're trying to access your database, but that shouldn't be possible anyways. You should have that all locked down with all the normal methods, passwords, and login, there's all kinds of things you can do to protect databases, right? Disable unneeded ports and services. Why would you have more things open and exposed to the world than you should? So you need to disable things that aren't necessary. You need to know the difference between TCP and UDP. You've got 0 to 65,535 TCP ports that can be connected to, and 0 to 65,535 UDP ports that can be connected to. Yeah, I think got it right. You need to enforce account management policies. Deactivate default user accounts. Have you guys looked at, when I pull this up, where's this at? Where's our log? Where's our Ranger cam at? So you go to Grafana. There's Ranger. What's Ranger doing down there? Hey Julie, look at Ranger. What's he doing down there?
He already ate.
He already ate?
Yeah.
Now he's just looking sad. All right. I want to show you guys something here real quick. Look at these accounts that try to log into my system at all times. There's always a bunch of them. If you guys haven't noticed, let's just count them up. Is admin probably like a common like default account for people? Sure. How about sysadmin? Probably. Info public? Maybe not. How about root? Root's always there. Test? Probably there pretty often. Pi? If you're in Raspbian, sure is. Admin? Sure is. Selena? That's a guess. Root. How about this one? EC2 user. EC2-user. Did you guys know that that is built into every single Amazon instance, EC2 instance that of Amazon Linux 2 and Amazon Linux 3? That's the default user. A Suarez, ABC, that's all bullshit. Terra, that's bullshit. Root, yes. True, or test, yes. Martin, no. User 1 data, that's kind of garbage. Root, yes. Admin, root. Look at all those roots. They don't even know that they're knocking on a wall. They're not even knocking on a door when they hit root. At least in my lab. Admin, root, Dennis. The hell's Dennis? Hell, he doesn't even have 2 N's in his name. That's a sad looking. All right. Anyways, the point is, enforce best account practice and get rid of accounts that you don't need. Keep best practice around account management policies. Audit your users. Get rid of them if they don't need to be there. Hey, Jose Souza, how's it going? I am just sitting here munching on candy and talking. Keep your antivirus or whatever tooling you're going to do up to date. Don't use CrowdStrike. Make sure you have something watching your system. And then host-based firewalls. Your virtual network should already have hosts and things protecting you, but within subnets you can also protect further servers further. A firewall keeps mistakes from accidentally happening. So I tell you guys this sometimes. If you turn on a firewall and only allow port 22 in your system, but then some admin comes through later with Ansible and accidentally installs Apache on all your servers, right? They just mess up, and they didn't mean to do it, right, guys? They didn't mean to, but they put Apache across all the servers instead of just the 3 that they meant to. Well, if port 80 and 443 are now open on your server, but you've got a host-based firewall that's only allowing port 22, does anybody still have access to those other ports on your server? I want you to think about that. If you haven't messed with this or you want to go prove that to yourself, we have labs out in Killer Coda that do uncomplicated firewall, UFW. Or you can just go put them on one of those Killer Coda boxes and test. Can I communicate, or can I what was I saying? With a service, even if it's supposed to be locked down. All right. So these are things to think about. And then this is what that kind of looks like. We've got AWS, we've got an internet gateway, and that internet gateway is connected. So every subnet gets connected to a route table inside of AWS. It can go to the default route table. They're just shown as router here. Or you can have different ones and then connect them. But the difference between a public and a private subnet have nothing to do with the name. They have everything to do with whether or not the route table that's connected to that interface or to that subnet has a path to the internet gateway. So question, if you use that wildcard to disable access and 22.3389, would you create a site-to-site VPN to connect remotely to your network? Yeah, Jose, you can do that. You can use a VPN to connect and then give access from there. What I tend to do is I have a box that sits in the DMZ as my jump box. So anybody can jump into that server that I was showing you guys earlier that people could connect to. That server really can be connected to if you know how to get into port 22. And once you get there, you use that one to cross the boundary into all the tasty data inside of my network. That's kind of the way that I look at that. Check this out real quick. I'm going to pull something up for you guys here. I'm going to go over here. I'm going to pull this up. I'm going to go to AWS console here. Remember, we're always accessing everything through an API. In here, we've got some user, right? Some user, and then some password. I think I know the password to this, maybe. Nope. All right, so I got in. I did know the password. Yep, tasty data. We don't want people getting at all of our tasty data. Get rid of our linear tape open. We don't need that anymore. But I come in here and I go to my VPCs, right? VPCs, Virtual Private Cloud. And I come in here and I just want to show you guys this. If you haven't seen this, this got really slick in the last couple of years where you could do this. We can go see all my VPCs, and my project VPC is here. But I've got some subnets that are public and some subnets that are private. And then any of my subnets that are out there are connected to these different route tables. Remember I said there's a default one up here, and then there's each of these. But I want you guys to look at something. If I'm on this one that says it's private, does it have a connection to the IGW, the Internet Gateway? No. This private one does not. This private one does not. This one does not. Not. But the public one does have access to the Project Gateway. So I want you guys to think about something here real quick. If I didn't change the name of this one, it's over here to the private subnet, and then it's the private US West 2C route table, if I didn't change the name of any of this, but I went in here and I edited this and I gave this a route to the internet gateway for the project, this one right here, even though the name was private, and even though this name is private, would that still be a private subnet? Or would it, by nature of being able to connect to the internet, have become a public subnet? And I want you to think about that. This is not just an AWS question for a certificate or anything, a certification. This is also an AWS question for, well, how do I manage my data and keep my shit secure? Because one of those answers gets you compromised by the internet potentially. One of those answers lets your users do stuff that they shouldn't, and the other one doesn't. So I want you guys to think about that, because this is very important. And it's very nice that it's visual now. You could visually see what's connected out to the internet. All right. These are all the things from earlier, but I'm just showing you where they apply. It becomes public. That's right, Jose. It becomes a public subnet regardless of what its name is, if it has access to an internet gateway. Now for you, for any of you, you probably want to change its name if you're going to do that crap, or just rethink about what you're doing. But my point is that's where the definitions come from, and the definitions are there to kind of protect you from yourself. So, all right, troubleshooting cloud security. All these things are things that people complain about, and all these things are things that can be dangerous in the cloud if you don't go learning about them before you just start launching stuff out in the cloud. One of the things about doing cloud processing and cloud data is it's super easy to get out into it. You guys can be building stuff while I'm talking right now. There's a blog, I have a blog post open for deploying stuff on AWS Amplify, just because I wanted to check it out a little bit. And there's some cool stuff out there. But all of these things are dangerous. All of these things can cause you to potentially have issues in your systems. So, all right. I'm not going to go through all of them because it's getting late. I'm almost to 2 hours, guys. I'm kind of tired. So, this is something I talked about earlier. Migration planning. This comes from one of my other slides, but security as a foundation is easier than security as an afterthought. It is very difficult to put security in place later. You should build it systemically. It should be deployed as your stuff is deployed. Your stuff should be deploying automatically and automagically, right, in an organization. It said automatically twice, even though I definitely said automagically. It won't let me look like an idiot, guys. Well, no more than normal. Your strong identity is your outer wall. You don't have physical security anymore to lock people out. So you need to understand how access works. You need to trace things, monitor, alert, audit, be able to take action. We talked about this earlier, but layered security. You have to assume that anything that you do can be compromised. You can't just be like, oh, I put up a firewall. Firewalls always work. Firewall's the life for me. My server's secure. Because then somebody clicks on a link and gets a reverse proxy set up, and now all of a sudden you are open and exposed, and people can connect back to you, and then you're mining Bitcoin, and your data center costs are through the roof because you're pushing data everywhere. And we had one when I worked at AAA. We got a cease and desist from HBO because somebody was hosting HBO's Game of Thrones out of one of our IPs, one of our networks. Something was an open relay. This was before I got in there, but I heard about it. And yeah, they were like sharing out. I don't know what any of that stuff with the dragons and stuff, but Game of Thrones stuff was being shared out. So we got a cease and desist from HBO at AAA, or at AAA. So it's kind of funny. I didn't say Triple X. What? I said AAA. Oh god, now banned from streaming. All right. Protect your data in transit and at rest. Automate things for best security practice. This one's big. Your mechanisms and tools can reduce people getting direct access to data. They shouldn't be hitting CP or SCP and copying things. It reduces the risk of mishandling, modification, people downloading stuff to their laptops and then leaving it open as they're in like a cafe or something. It just keeps the data away from people. Pipelines are designed to do that. All process management and CI/CD is designed to protect people from themselves. So do that. And then you got to prepare for your security events, because you can't fight better than you practice. There's kind of like a saying like that, where if you can't do it slow, you can't do it fast. Well, in a security incident, that is not the first time you want to be opening up Wireshark or Slurm, whatever tool you're using. Slurm is a good one, but it's more of a data processing thing. But anyways, you want to run response simulations and tools, and you want to get these little things like backdoors and breaches, and play security incident games with people and get better at handling how the data is going to go. I don't know if you guys have played with that, but Backdoors and Breaches is a fun little game. It's a play on Dungeons and Dragons, but it's with like an incident team. So yeah, game days are never prioritized. That's true. They're the first thing that'll get pushed, especially if there's an incident that it might have helped you with. That's funny. All right, so there's our review. Those are the things we talked about today. Those are kind of the things that I spent the last couple hours talking about. Hanging out with the wife. She brought me some candy. I'll probably get off of here and we'll go play some video games. Is Sending, you should stream. You are fishermen. I'll go raid you guys. Let's see if anybody's on. Is Fisherman on? He's been going every night. Nah, he's not up. Where you at, Fisherman? It's only 11 for you. You Fisherman's young. He can still be in the DGen hours doing DGen stuff. Yeah, I'll stay on for a little bit. See if he somebody go ping him in the Discord and see if you guys can get him to stream. Let's see. At Fisherman. Get to streaming. There we go. Boom. If you guys don't know, the Discord is there for you guys to. He must be fixing the bot right now. But the Discord is there to give you guys a place to hang out with other people, be more persistent. We have like almost 2,400 people in there. Like it's getting pretty big. You guys are, that's always going to be free. We do events. The guys come and talk. We throw some of them up on YouTube. I promise you guys I'll record mine one of the days, but everybody else did very technical stuff, and mine was very generic around concepts and engineering that I think will make you a better engineer. Understanding why we do it, how we get paid for it, what the value we bring to a company is, those kind of things. All this other stuff, this technical stuff, you can go read about this, you can learn this stuff. But some of this stuff, you just got to spend some time. So if you got questions, we got a little spot in the Discord where you can ask me questions, and just get in here and do it, guys. Like I tell people all the time, even if you think you're useless, you can be used as a bad example, right? Nobody's useless. But the point is, what I mean by that is, if you can watch me do this stuff and go, man, if this guy can do it, I can do it. You're right. If I can do it, anybody can do it. So get in there, get yourself some skills, learn. Gosh, you don't have to do something like, you don't have to be like, oh man, today I'm going to go do Linux for 8 hours. Oh gosh, I'm going to hate that Linux all day. Find something else that's interesting. But Linux is a good base for engineering that you can then go spin off and do software engineering. We got software engineers, we got security engineers, we got people that like to play up in the cloud all day long. Some of the people do sound engineering. We got a couple of sound engineers. I know because I'm one of them. I'm not a very good sound engineer, but I do it. It's fun to me. Not the sound that's playing on my background. Jeez, God, that music's terrible. Hold on, I gotta switch the song. It's supposed to be scary, but it's just annoying. Sorry about that. I'm in my dark streaming music here. We'll go to our chill. Hold on, where's our stream and chill? There we go. As I get ready to get off of here. All right, guys. Keep working on getting better at this stuff. We'll go raid BlazeBits, see what he's up to. You guys over on YouTube, thanks for coming by. Come hang out in Discord sometimes, and I will see you guys probably later on this week. Take care. Oh, actually, no, I'm going to be out of town wrestling until Sunday night, Monday morning, so shoot, I might not see some of you guys except on Discord. So, all right, take care.